So I don't really have any agenda items for everyone generally. Lindsay has put some announcements up there about a subsurface meetup on Thursday at 8 a.m. Pacific time, a curve note meetup at Thursday at 10 a.m. Pacific time. And on Friday, there's a subsurface rendezvous, which I'm sure Dieter can tell us a little bit more about as well. I remember you pinging me about that with the portable interactive plotting stuff. So looking forward to seeing that. Tom, did you have anything that you wanted to discuss other than that?
No, I mean, the cool thing is that Mira is going to push real hard on SimPEG in the next year. We are onboarding someone to work entirely with me on this, so we'll be pushing really hard on it. So that's good news for everybody.
Any specific areas you're targeting?
Basically, we want to be able to get to production level, DC first, MT second, and then the well, I guess MT frequency second, and then time last. So that's going to be kind of like the hit list for the next year.
Yeah, the tiling for the MT, it's so nice to see things going faster now. I did that L block model. Yeah, I think I got it down. It was down to like 5 minutes, 6 minutes in iteration, nice. Where UBC is at 12 minutes or something like that. So
very nice.
The tiling works well.
Yeah, I did testing with the gradient array back to DC, and the DCIP3D. If you have few sources but lots of data or a big mesh, it's so slow, right? The parallelization doesn't really kick in. So we're really killing it, be able to slice transmitters, and yeah, it's we see the competitive advantage of pushing the code, so it's going to happen for sure.
Tom, you will be able to join tomorrow for the subsurface catch-up?
At that specific time, she said? Oh, Thursday. Okay, yeah.
Tomorrow
at
8 your time, I think, yeah. Because I just had a little chat with Miguel, and it looks like they're far enough that we could, at the hackathon, which is in a month or so, that we could like bang our heads together and bring it into different libraries. So one would be SimPEG, but the other one would also be interfaced with GeoSci.xyz.
Yeah.
So it might, we might get a big push there. Would be cool.
Okay. Do you have a link? I see the thing in the curve now, but is there a? I just go to subsurface.
I think either I put it already in subsurface or I have to. Good, you remember me. I will check afterwards.
Yeah, if you could just add it, and I'll join. I have I'm available tomorrow morning.
Yeah, cool.
One of the things I think would be interesting about parallelizing DCIP code, where it's like you've got a bunch of receivers but only a couple sources, would be to somehow balance it and shift it around, use the reciprocity, take advantage of the reciprocity to do more parallelism.
Sounds great. Yeah, and that's the tricky part right now we have with tiling is, again, rehashing the same stuff, but the receiver locations are kind of hidden down the path, right? And it's kind of hard to figure out the spatial correlation between transmitter and receivers. You kind of need to go down the chain and come back. Anyway, yeah. That would be cool though. Joe, go for it. Mix it up.
Yeah. Well, then, so Devin, you want to talk a little bit more on progress that you've been doing with the DCIP stuff?
Yeah, I mean, I think I went through most of it, but just making lots of progress on upgrading and cleaning up the utilities. So I've got an IO for XYZ formatted data, and just considering things like whether or not stuff is getting reorganized and keeping track. Plotting utilities, making sure that that things are kind of named according to SimPEG, all that stuff. So I've been making some good progress on that. Not quite finished yet, but I really do want to figure out that 3D plotting bug. It's super weird, and we can't have that figure rendered.
Mm-hmm. Yeah, well, I'm having it build locally on my machine too right now and see if it reproduces that.
Yeah, that would be great. Because I mean, I did something similar on the last, I think, SimPEG release. And so I think the website that's live right now actually has one of these bogus 3D plots on it.
Gotcha.
Yeah, so that's
Okay.
not.
Another thing, I know you were talking about how we had the like 2D versus 3D receivers and the structures of their locations and stuff.
Yeah, I've been working on making the I guess the package robust so that you sort of can't screw it up in the context of having surface surveys versus actual 3D spatial surveys. The easiest thing to do right now is if you load in any data, it would, and you don't have a an elevation for it, you would basically assign an elevation of 9999. I mean, basically that's taller than Mount Everest. So if you did then get a warning that said you need to assign topography, and you would, those points are above the surface and will then find the closest surface. I think for tensor meshes, it doesn't matter where those Z components are. If you say reset the Z value based on topography, it will find the surface. But I think with tree meshes, it might actually find just the closest active cell center or node. So if you just gave them a value of 0 and your topography was above it, I'm not sure that the sort of drape over topo would actually shift them properly. So
Right.
I just pick something by default that's really, really high, that's obvious, and then it'll always be projecting down onto the surface. And that seemed like a really quick way to make sure everything works without doing anything fancy. But the general idea is that when you load any data into SimPEG for DCIP, either whether or not it's 2D or 3D, that last positional value always has to be the elevation. So you could either load a long line in elevation, or you could load X, Y, Z, but you wouldn't be able to load surface data with like a null elevation location and then play around with it. It would stop that from happening.
Yeah.
Is that everyone sort of following along with that?
I know the tree mesh still needs to be updated. Dom had put a issue that was like, basically I made a comment on an issue. I made an issue already about it, discussing it, but it was like, so what the tree mesh does right now with that drape topo function is it was written to just literally find the closest cell and move them to that cell.
Yes, and it
And
would be, it shifts stuff, and I noticed that in some of the scripts I was writing, and it would be nice if it actually projected downward, and if it was say 3/4 the distance, it would actually go straight down instead of just, because it will project horizontally at times.
yes.
I
So,
noticed that, yeah.
I have a general idea of what needs to happen in my head. It's kind of a little, it's still abstract, but we essentially just need to extract the boundary cells from a tree mesh, like along that topography surface, which there are functions to do that right now. And then like generate a 2D tree mesh based off of that like, topography. And then project it onto that, because you can't just use the closest, like a nearest neighbor tree lookup for it, because it won't work great all the time.
Yeah.
But
Yeah, I'm not too worried about that. One question I had maybe for the group is that there's a drape over topography or shift to discrete topography that is, it's a method of the survey class. And if you apply it, then it'll output the survey that's shifted. But there's also a function in utilities that will give you the location. There's also a drape topography function in there that I don't know if I think maybe we need to move it out. I think it's doing the same thing.
I think the one in the survey is calling that one.
Yeah. All right, I'll double check that, but Yeah, it seems like it would be useful to have, I guess. It's just you'd want to know what the new locations are. Figured you could just call it from the newest survey.
Yeah, I'll have to go back and check. I thought it just like literally overwrites the locations and updates the locations.
I think it outputs a new survey. Oh no, I'll double check. It's, yeah, work in progress, but it's
Okay.
happening.
John, I think you got some stuff on next, if you don't mind.
Yeah, yeah, nothing too much. Just yeah, hooked yeah, Dom went in and changed the receivers a little bit using the INSUM stuff for the impedance on the MT receivers. So I just updated that for the apparent res and phase. So now it's working with tiling. Made a couple examples with it, and yeah, now I actually dabbled into the grounded source frequency domain stuff, playing around with it. Yeah, we're doing quite a bit of CSAMT here. We've got a few projects, so I thought, yeah, try and see if I can simulate some stuff.
So you're able to use like the grounded sources with the MT receivers.
I haven't done the MT receivers yet. I was just using the frequency domain stuff, just using E and B, and yeah, just looking at it that way. But the next will be the MT receivers for sure. See if it works.
Yeah, I think that was like one of the good consequences of unifying the code, that we can use, like we can combine the different ones for those type of problems.
Nice. Yeah, I'll probably tackle that today and see how it goes. I'll let you know.
Cool. Yeah. So I pushed out a few of those changes to discretize. It's got a patch version now, a bumped patch version. It has the updated refined functionality for the tree mesh in there for the boxes and balls. Can refine around those pretty easily now, and we're consistently. So that got all pushed. The documentation's all there up on discretize, on the discretize docs. It's all just nicely happened whenever you tag something, which is great. And I've also been trying to go through, and I've gotten like those kind of boundary condition things implemented for the tree mesh that I've talked about before, and I'm working on them with the curvilinear mesh right now. And I'm kind of running into some odd issues as far as approximating. So what I'm testing it on is I'm testing on this curvilinear mesh that is deformed to look like a sphere. So I'm trying to, it's a really weird thing to think about, but you're basically discretizing the sphere up into, boxes, deformed boxes, and you can get it to be,
That seems fine.
yeah, but it deforms it in this box, and it looks weird, but it's still all like, structured, but it's just a structured sphere. So I'm doing tests on inner products with that kind of system, because that's something that only the curvilinear mesh can do for us right now. And it's also a little bit easier to calculate, volume integrals in spherical domain on a crazy mesh like that, right? As far as opposed to like, creating a weird shaped mesh and trying to approximate a volume integral on a weird shaped mesh that you don't know the analytical answer to. But anyway, so that's what I'm trying to do, and I can't figure out if the errors are in like using SimPy to do spherical integrals, which certainly possible, but I think I've double checked, and it's giving me the error, like for simple functions, it's giving me back what I expect it to. But I can't get like the numerical result from the mesh to agree with the analytic result from the integral from SimPy. And I can't tell if it's happening on like the gradient or the divergence operators when they're multiplied by things, but I've been trying to figure that out. Like, I'm not even concerning myself with the boundary conditions just yet. I'm just trying to approximate, the gradient of a function times a vector. And I'm having issues with that. So I don't know, and I don't know where it's wrong just yet. But I'm going to be going through a few more of those tests. Other than that, like the boundary stuff works just fine in tree meshes as it was written, so that's good. I think I want to kind of pull it in soon with just the basics, like the basic components for the boundaries. So not necessarily having like the weak form of the cell gradient implemented for every single type of thing, or like the weak form of the phase divergence boundary condition thing. At least for now, like since I talked to you guys last week how I have those kind of basic building blocks in there, I think we can get those out first, and then keep adding on some of those automated building of those other matrices as we're going on, because we can start working off of this and incorporating it into like because the MT branch that has the 2D stuff will be reliant off of it. We want to get that probably into SimPEG a little bit quicker.
But I guess remember that, okay, in one case, you would actually be calling, let's say, the phase divergence, and if you applied certain boundary conditions, it would actually be returning the phase divergence with those boundary conditions. The other case would be if you were doing the edge divergence, in which case it'll be the sort of natural phase divergence transpose plus a piece. You have that second one figured out, but not the first one? Or did I just...
So what I have right now is I have like the boundary integrals defined
Okay.
for like the different types of meshes. So meaning like you have a function that's defined on a boundary, and we know how to integrate that for the mesh. So that's the part that we need for the boundary integral for the three different types. We got like, the edge. What happens when we have like an edge vector and an edge scalar or something like that multiplied together around the boundaries? We have the edge vector, edge scalar, or edge vector, face vector thing that happens when we get the curl product. We have like all the pieces that are there to do what we need in the future.
Yeah.
So what I mean is like let's say we have like a Robin boundary condition that is a little bit different for each type of those, like the weak form. So right now, I only have the Robin boundary condition for the weak form of the cell gradient. But the pieces are already there to implement them for the other parts.
Yeah.
It's just like already having something automated here to do a more user-friendly version of putting all the pieces together for you and then giving you back what you want.
Yeah, I mean, I think that's a good idea. I just want to be really careful about what it's actually called, because I think we had one kind of situation where it was when you ask for nodal gradient, it makes complete sense. It's actually a discrete gradient operator. It goes from nodes to edges. But then historically, when you were calling the cell gradient operator, it wasn't actually a cell gradient operator. It was that with an inner product matrix, because it incorporated the boundary conditions. I want to be really careful in the naming, or if you want to group stuff together, to not call it something that it isn't.
So basically what we were talking about, I think what Sagi and Lindsay and I were discussing earlier, is that so when we're doing the cell gradient, right, when we use the phase divergence for the weak form of the cell gradient.
Yep.
So it's named after, okay, it's cell gradient weak form boundary condition.
Yeah.
That means it's applied to the phase divergence operator, because that's the weak form of the cell gradient. And then the same thing would be like, okay, so the nodal gradient is the weak form of the edge divergence. So it'd be like edge divergence weak form boundary condition or something like that. And then correspondingly the face curl weak form boundary condition. So it's named after like the thing it's replacing.
Yeah, and I guess when you're talking about putting all the things together for the user, I'm wondering like to what extent are you doing all the work for them? Because I would like the idea that if you went through the derivation, did the weak formulation, and you said, I want a cell gradient, that you would actually be saying, actually, no, I want divergence transpose plus this piece,
Plus the
and
boundary.
then I'm going to apply the inner product. Like, you know what I mean?
Mhm. So what
Yeah.
I'm right now, like those little pieces are called like, things like boundary face scalar integral or something like that, where it's just like, okay, well, I'm integrating a scalar value along, along this boundary dotted with a vector test, something like that.
Yeah.
Or named after like directly what the integral looks like.
Hey, Drew.
Yeah.
Any chance to implement the forward final difference operator in the discrete size? Yeah, we talked about a checkerboard pattern
Oh yeah, for the
problem. If you can
talking
still
about having like the forward difference operator, it goes from this forward cell difference, it goes basically back to the cell it started on. So it's useful with like what he's talking about there when you're doing the cross gradient terms. It's nice to have a forward difference operator from cells that operates those two cells. That's something like we need to get that as well in there for that. Like it's something that could be useful there.
Yeah.
So it should be close. We should be able to do it pretty quickly because it's just a matter of putting it in the right place afterwards. That's not. So what ends up the reason he's talking about that is, so if you have a forward, right now we have the cell gradient operator that goes from cell gradients to faces. So if you do that, and then you average the faces back to cells, it gives you a centered cell gradient. And it ends up with like a weird checkerboarding pattern, and it's just kind of weird. So you kind of have to use it for the cross gradients in terms like that. You need a forward cell gradient operation to make sure that all the cells are linked up properly. That's something that we can get in there.
Yeah, sounds good.
And yeah, I'm open to their names as far as those like boundary integral products. And I think I talked about the last time I was showing you guys, just looking for input on what to name some of those, like the equivalent of those inner product matrices. So like in inner products, one's called an edge inner product matrix. That is a face inner product matrix. So kind of makes sense to call them like boundary integrals, boundary integral matrix. So I was kind of going after that as far as the other names of what they are. Go on. So also Lindsay has some items there that I'll just list for her since she's not here. Just like to thank everyone for their input on her cyan presentation that she gave yesterday, I believe. It seems like it went well. She'll be doing an EMNR next week that she'll likely be sending slides around for people to check out and would appreciate help on that. They have the inversion module live for CurveNote on CurveNote, which is what Doug has. I'm not sure if it's still going actually or not, but it was what Doug was using for his EMNR today. Liz put in some work on that, helping him get them all ready and everything. Oh, and then she has a comment on Devin's question that he put in there, which we didn't really talk about, is where should tutorial data live?
Oh, yeah. I guess the idea was to not add a bunch of heavy files to the SimPEG repository. I mean, we don't want to be like saving factorizations or sensitivity matrices and stuff, but I didn't see the problem with how, oh, and I guess, yeah, if you have a larger octree mesh, like it adds up. There was this idea of putting it somewhere on a cloud or somewhere in the interwebs and downloading a file and unpacking it. But we can't put it on UBC's own cloud because then only UBC employees would be able to access it. And Lindsay put it on, I think, a Google cluster or Google Cloud account, which meant I had to sign up for that and pay some fee, and that was a nightmare to get set up with. So where things are living now is maybe fine if nothing changes, but it's been a nightmare for development if any of the data files change.
But this, well, no, it doesn't fix the hosting, but the fetching could be done with Pooch, right? That's kind of the case for which Pooch was designed. So even a user, it would only download it once and would cache it properly. And but that doesn't solve where you should host it. So yeah.
Yeah, and that we have like a download utility that will grab it if it's a file from the internet and unpack it. Like that's all fine. It was just for developing stuff right now. If I change the mesh, if I decided I wanted a different electrode spacing, or I wanted to show something else, now I have it's been frustrating. I've had to change some of the tutorial scripts for what I'm developing currently, because if I want to do the forward problem and then the inverse problem, the forward problem has been changed, which means the data is changed. And if the inversion script is now downloading something automatically that I can't change, then I'm not sort of doing the forward and inverse problem on the same data. It's just.
But like a Dropbox or a Google Drive, or I mean, that should be enough, no?
Sure. I mean,
would be.
I'm kind of fine with anything for right now. Like I'm just keeping lightweight files as part of the repository, and when all development's done and everyone's happy, we can find a place to put it. But I'm just saying, as of right now, if I make changes to the tutorials that result in changes to the data being output, then I don't actually have access right now to go and change what's up on the internet. So that's a problem for development.
Sorry, it looks like it just finished building, but there's definitely, my thing just finished building your documentation branch. But there are a bunch of errors. Where was which tutorial were you talking about?
Can you just, okay, it would be, well, just take a look at like a DC resistivity one and just look at the 3D forward modeling. I mean, yeah, you're on my branch. I don't know what kind of errors that you have. Can you show your screen?
Yep.
That's a lot of broken stuff.
It's all, I think a lot of it's broken because like there's no deprecated functions.
What branch are you on? And did you?
I am on TCP TCP update utils.
Yeah. Did you actually like build SimPEG again?
Yep.
Huh. Okay. I'm not sure where it's broken or why it's broken yet.
Anyway, so I think I just saw something like that. So is your plot in 3D?
Yeah, that's a happy one. Well, that's a 2D plot.
Right. So it's, oh, I guess that's voltages. Okay.
Yeah. So I made pseudo sections take into account topography, which was.
Yeah. Let's see.
Oh, yeah. What's
Oh, you don't, like, I don't have this XYZ topo. That's what it is.
Huh. Okay.
So, okay. Yeah, we don't have that on here. So it goes to that problem. Where are we storing this data right now? Those data files.
Oh, I'm going to check the Git ignore, because it might have chosen to ignore a bunch of all that stuff when I push, which means you don't have it.
We should, so yeah, right now, the way it works is they're on this Google Bucket account. So you shouldn't have to pay for it, Devin, because I remember getting on there and I have access to it and stuff, but I don't think I had to pay for anything.
I got access to it, and I tried to log in, and then, I mean, I was busy and it was just taking way too much of my time, and I couldn't figure out how to do it. And then I just kind of gave up on it. But it wasn't I got sent the link to where it's supposed to live, and then Lindsay gave me access to it. I clicked it, and I assumed it would take me to a place that would let me browse files, and it didn't.
Yeah, it's a little bit odd the first time you're looking at it, but yeah. I wonder if it would be sufficient for like temporary development, whether you could just like have it on a Google Drive that it downloaded from every time or something. I just have it linked to a Google Drive.
Yeah, I mean, as of right now, while I'm developing stuff, I'm gonna keep it locally, because and then when we decide to go and bring it all into to the main branch, we can totally package stuff up and put it online, and I'm totally fine with that.
Yeah.
So,
But the only problem, like in the meantime, it does keep track of all of those files, like back and forth. So like they're always in the history.
yeah, one of the things that I've done, which is something that actually needed to be fixed, is when I was doing the forward simulation and basically creating assigning noise and creating the data that would be used in the inversion, I didn't fix the seed for the random noise, which means every time you run it, it's going to generate a new data file because new noise is being added. That's something that needs to get fixed. So I don't know, those little details. I guess I'm just saying, for just being able to go and update stuff like that, it's been not as easy as I would like it to be. This hosting it online has not made my life easier.
Yeah. I mean, the only point of it, it's not really a convenience thing, unfortunately. It's just a matter of we don't really want it living in the repo.
Yeah, and that's fine. And I agree. It would be good to have a place online. I mean, I thought, why couldn't we just put it in like have another repository in SimPEG that houses this?
I mean, that's an option, just having a repo of like, testing files or something.
Yeah.
Data.
Yeah, I don't, because then if you have access to the SimPEG repository, you would automatically have access to everything under the SimPEG umbrella, which means you would have access to this already. It seemed really weird to store SimPEG related things in a third-party place. That just seemed kind of weird to me.
Not necessarily, because GitHub is code, right? It's not data necessarily.
Yeah.
And I think part of the reason for that is like GitHub places, or they used to at least place some restrictions on the size of your repos. So
That's true. But so doesn't everything. Dropbox does.
Well, I think they were much, like, the size of your repo is much more limiting than the size of a Dropbox. Like, you can pay for Dropbox,
Like,
and you can get a terabyte of space. So
okay.
Like big data files, you want to compress anyway, and that's really not for version controlled systems in a way. Compressed data. Like if you do 3D modeling, you probably don't want to keep it as plain text because it will blow up, right?
Yeah, no, I agree. We need to find a place to house it.
But yeah.
And that, yeah, it's not what GitHub is meant for.
But I think what you mentioned, temporary, you can just having a data repo is a good solution, because then it doesn't affect the SimPEG repo and it doesn't blow up the SimPEG repo history, right? You can always delete it again. So I don't think there's harm in that.
Well, I guess another thing is, I'm wondering what happens in the if you're developing stuff and you're going to change those data files, then you're kind of using the same data files in your development as you are using on the live version. And I think then we'd also kind of have to be careful of that.
Yeah.
Or you just have to be smart about it and know what you're doing.
Yeah, I don't know what the solution is really. Lindsay had posted like Zenodo or what was the other thing she had suggested? Figshare.
Figshare.
I haven't used any either of them, so I'm not sure.
Okay, well, I guess for now, I was hoping to just finish the development of these utilities. When everyone's happy, then we'll package it up in a place where it should live. And I can take another stab at trying to put it where things are now. But it was not easy. Maybe somebody could give me a tour. Maybe all it takes is like a 5 or 10 minute show, and then I'll know what the heck I'm doing up there. But it wasn't inherently obvious.
I remember the first time I got on, I was like, not sure what's happening. And you have to set like the right permissions for the file as well.
What is that? It's a Git, Google.
It's a Google. It's like a bucket, Google bucket or something.
Google bucket. Oh, okay. Never used. Yeah.
It's just like it's their cloud storage. Okay. Well, is there anything else anyone would like to share?
Yeah, maybe I'm gonna zip the files that I have locally, check the git ignore. I'm gonna send those files to you so that you can actually build the website. And I really do want to see if you're getting something different.
I guess one quick question. I don't know if you've seen the discussion I have with Tom. What he meant with the coordinate system, so what are the different systems you use within SimPEG? Because he mentioned that there are different possibilities, right?
Yeah. From what I understand, like the standard Cartesian coordinates are all a right-handed system.
Yeah.
Make of that what you will. If you really wanted to be really weird about it and not worry about like have your own definition of where the model parameters are, you can have X, Y, Z refer to whatever you want as long as it's still a right-handed system. The equations are all valid. Right? You could have everything set up to where X is north, Y is easting, and Z is positive down. It's still a right-handed system. The equations all work.
Yeah, the issue I think comes with the angles if you use angles.
Talking about like azimuths and
yeah.
angles. I think our current convention is that azimuth is direction from like clockwise or counterclockwise from north.
Clockwise from north. Right.
Clockwise. Clockwise.
Yeah.
Clockwise.
North towards east.
Yeah.
Yeah.
I don't know. Dip is pretty. Makes sense. Right. It's from horizontal.
Down. Yeah. But then I think he said dip in Mac is differently. It's from downwards. From.
Yeah.
The locations would be easting, northing, upwards. The inclination and declination would be whatever the standard definition is. Gravity was done. Somebody said that somebody switched the gravity one to be a convention where gravity anomalies would be high over more dense structures, even though gravity is a vector pointing downwards. Mm-hmm. Somebody decided to make that the default.
Not me.
Yeah.
It's not true.
I kept everything XYZ, and but somebody was like, no, this is the convention, and it got merged in. So that's gravity now.
The gravity convention is, it's, you know, it's a right-handed coordinate system, z's positive up. So that means over a denser object, it is more negative.
Yeah, that's how it was originally written. That's
Yeah,
how I wrote the tutorial. And then I thought somebody complained and said that they wanted positive values over dense things. And then the code got changed, and then it got brought in.
I don't think I've seen that anywhere.
No, I don't think that's how the code's working right now. At least not the code that I'm running and doing inversions and stuff with. If I want it to match some of the stuff that I'm looking at from other people, I definitely have to flip, like reverse the sign.
Oh, okay. That seems to be.
Hi, Lindsay. We were just going through, I went through your your notes there. How was the M&R?
It was good. Yeah, great. Yeah, great attendance. I think there were about 170 people, Alan said, at the max, which was excellent.
Wow.
And then, yeah, lots of questions at the end. So it ended up sort of being a 2-hour event. So I'm sure Doug is pretty wiped. But it was a great talk, and I think it'll be a really useful resource. So it's good. So now he's set a high bar for my talk next week, which needs to be started right now, but that's okay. We'll get there.
Everything went well yesterday.
Pretty well. Yeah, I slightly mixed up the times. So thankfully, you know, I thought it started at 1:30, but it actually started at 1:15. But they said in the email, be there 15 minutes early. So thankfully I was there 15. I thought I was 15 minutes early. I was on time, but late by a minute. So thankfully, you know, they started with another speaker, but all went well. It was a good session, and it was a lot of folks from sort of like big national labs, HPC facilities. So it's kind of cool to see a bit of a contrast, or that we kind of provided a bit of a contrast, being sort of a bit more of a domain focused project that's like a little more multi-stakeholder, not sort of the you know, part of the like direction or scope of what is done in a national lab. So yeah.
Cool.
So thanks for all of your help.
Sounds good. Okay. Well then, so if there's anything else to talk about, I think we kind of made it. Do you want to, we were just talking about like where we were storing things and stuff. I saw you'd put like Zenodo and whatever the image thing on there. Like we haven't really talked about too much. Well, obviously I haven't made any decisions, just a challenge to figure out where we put these data files and have them be accessible and easily modifiable for developers.
Yeah. One thing I was wondering, so there's like a few avenues, and I haven't really looked into any of these. So I'll just throw this out as if anyone has time or interest to look into places. So I did mention Zenodo and Figshare. I don't know if it's quite the right fit because it's not like a publication. So I wasn't sure about that. The other thing I was wondering is like how hard it would be to set up a little web forum where somebody can just like request that data be added to our Google Cloud and that it's a one-click button. I imagine somebody's made something like that in the past that we might be able to pick up. Yeah, that's sort of, I don't know if anyone else has other ideas or opinions on that, because it would be nice, I guess, like we need to have some sort of a little bit of control on like a yes, no, like admin authority if it's going to Google, so that, you know, we don't just become somebody's data storage warehouse. But it would be nice if it was a little easier than it currently is, because I appreciate it's kind of clunky, but Google Storage is a good place. It's a decent home for stuff. It's just getting it up there is annoying.
Yeah, and you make some good points about what else we could put up there beyond just these data files for tutorials. We also had a desire to put some, just kind of some stock data sets for each type of geophysical method that we could download and compare. So there's like the Cloncurry MT data, there's the Mount Isa data that we have freely available, and that would be a nice place to put this as well, to have tutorial data and then some like workflow or validation comparison type real data.
So Devin, you mean the field data and the synthetic data used in the tutorial?
So right now for the tutorials, I've chosen to work with synthetic data to keep the problems relatively small, to keep things quite simple.
Yeah.
But in the GIF tools area of things, I wrote some workflows to demonstrate that package's ability and compared it on real data, a workflow from start to finish on how you would tackle a real data set. And I'd like to reproduce those examples with SimPEG, and we would have a parallel comparison between both of them. So we have one for magnetotellurics, we have one for ZTEM, and we have one for DC and IP.
Okay, I see.
So it would be good to have those available to be able to compare SimPEG with.
Yeah, sounds good. Yeah, thanks for clarifying this.
Yeah, no problem.
Okay, then. We can get on that. With that, I don't think there's anything else we had on the meeting notes. And again, if anyone has anything else they'd like to share, speak up. If not, we'll see you guys next week.
Yeah, just let me know how the
Thanks,
website
Joe.
builds. I'm on the edge of my seat figuring out if that's what's going to happen.
Yeah.
I need to know, Joe.
Stay tuned for next episode.
See you later.